Charles' law is another one of the gas laws. It relates temperature to volume. So let's talk about temperature and volume of a gas. So if we increase the temperature of a gas, get hotter, then what's going to happen to the volume? Well, those molecules speed up. They're going to hit the elastic container more often. They're going to push it out and make it bigger. So as the temperature goes up, the volume goes up. Think about heating up a balloon or something, or a hot air balloon. It gets hot, it gets bigger. So as the temperature goes up, the volume goes up. This is a direct relationship. These are directly proportional. If one thing goes up, the other goes up. If one goes down, the other goes down. So things that are change in the same way, one goes up, the other goes up, are directly proportional. And so Charles' law of temperature and volume is a direct proportional law. So this is the formula. Now notice something. If you've seen Boyle's law, P1 V1 equals P2 V2, that's really simple and easy. And this one's a little bit more jumbled up. Notice that the direct relationships, since we express them as products, have jumbled up formulas. If we wrote them as ratios, we would see that they weren't as jumbled up. But we're going to write things as products because I think it's a little easier. But anyhow, what that means is, remember, for direct relationships, the formulas are going to have the 1's and the 2's all mixed up together. You're not going to have 1, 1, 2, 2. You're going to have 1, 2, 2, 1. And so that's a little tip. If one goes up, the other goes up, direct relationship, your formulas are more jumbled. So again, like Boyle's law, it is a ratio law. So it has before and after. But unlike Boyle's law, the units for volume do just have to be consistent, don't matter. But the other unit, temperature, must be in Kelvin, has to be in Kelvin. You might write that down somewhere in big letters because that is the most common mistake people will make with this. No matter what the problem says, if it mentions Fahrenheit, Celsius, it doesn't matter. You've got to get it into Kelvin. Kelvin is the absolute scale. Doubling Kelvin is actually doubling the temperature. Doubling 5 degrees Celsius to 10 is not doubling the actual temperature. So you've got to work in Kelvin. So, like everything else, it's only true if the things not mentioned in the formula don't change. If pressure is changing, you can't use it. So this assumes constant pressure. T1 V2 equals T2 V1. So here's an example of how we might do one of these problems. We have a balloon, has a volume of 25 gallons, 250 degrees Celsius. What's the temperature necessary to cause the balloon to occupy 10 liters? So let's figure out, go through and begin to label things. So we have, it has a volume of 25 gallons, that is volume at the beginning, and 250 degrees Celsius, that is the temperature at the beginning. What temperature, so that's a new temperature they're asking us for, is necessary to cause the balloon to occupy 10 liters, that is the volume at the beginning. So if we look at this, we have T1s and V1s and no pressures, and so we look and see what formula involves only T1, V1, T2, V2, and that would be Charles' law, which is T1 V2 equals T2 V1. Because pressure is not mentioned, so it's thought to be constant. Temperature changes, volume changes, so we can use this. So we go through and we calculate this. The temperature 1 is 250 degrees Celsius, but we cannot use that. We have to get it into Kelvin. So that's 523 kelvins. The volume at the end is 10 liters. The temperature at the end is actually what we're being asked to find, so we're going to leave that as a variable. And the volume at the beginning is 25 gallons. Now, if we're clever, we'll realize that doing this will give us the wrong answer. And any multiple choice test will give the whatever you get by solving this as an answer, because they expect you to do this. One thing we haven't looked at is units. Gallons and liters are not the same thing. We have 10 liters over here and 25 gallons over here, so that's not going to work. If we have to change one of them, I'm just going to change the gallons into liters, not because that has to be done that way. You could change the liters into gallons. It's all good. So we have 25 gallons, and I need to change that into liters. So I want to put gallon on the bottom to get rid of it, liter on the top. 3.8 liters is 1 gallon. So I need to take 25 times 3.8 to get the number of liters, which is 95. So now I do have the same units. I have 95.0 liters on the right, 10.0 liters on the left. I have my Kelvin temperature, and so now I'm going to divide both sides by 95 to solve for my temperature. So 523 times 10 divided by 95 gives me an answer to 3 sig figs of excuse me, 55.1 gallons. Wait, nope, I'm sorry. What am I talking about? Not gallons. We found a temperature. Temperature is kelvins. So that's a really cold balloon. So I believe that should work, and that is how you do a Charles Law problem.